Hey guys, hope you're doing well and enjoying summer this year. This is Pratik. I'm a Salesforce architect and I'm going to demonstrate how I use Salesforce and Qwen model to find the duplicates account records. This is just a proof of concept and I used basically two architecture here. One is the locally hosted Qwen model, Qwen AI model, basically. And for that, I used LM Studio. So the model was hosted on my machine, my laptop basically. And I used Cloudflare to basically expose the REST API through the LM Studio so that Salesforce can make those API calls to retrieve the response, right? And the another architecture that I use once I was through with the locally hosted Qwen model, I hosted that Qwen model on AWS Bedrocks. Uh, Same experience, but different configurations, right? Now, we already know that duplicate management remains a major Salesforce challenge, especially after migrations, integrations, and bulk data loads, basically. Marketplace products are also available, but they may introduce additional licensing, proprietary matching engines, or dependencies on platform such as Agentforce, Data 360, or maybe you might end up with sending your data to a third-party public endpoint AI or public endpoint, basically, right? Now, for this POC, I built Salesforce-native private AI duplicate assistant using Apex, LWC, and then Qwen. I selected Qwen for its strong natural language understanding, instruction following, structured JSON generation, and flexible deployment options. And for this local POC, Qwen runs through LM Studio, as I mentioned, with PowerShell gateway. So I created a PowerShell script and then temporary Cloudflare tunnel. So as I mentioned that I use Cloudflare tunnel so that I can expose it as an API. And for a scalable cloud deployment, it runs through Amazon Bedrock, which I mentioned that uh, basically all these steps of configuring it on the local machine, it's eliminated once you deploy your model to Amazon Bedrock, right? And then basically it remains in the customer's AWS environment, right? They can also go with the like the Olema or Llama or VLLM, NVIDIA, Azure AI Foundry, or maybe Google Vertex AI, right? Those are the other options or platforms available. The key benefits is basically it's customer controlled, right? So the model can remain within customer managed infrastructure without submitting Salesforce data to a shared consumer AI endpoint, right? That's a whole benefit. And uh, this is the architecture that on a high level, I can show that, for example, this one is a locally hosted machine. As I mentioned that this is the LWC Salesforce platform. I use the Salesforce sandbox to create this POC, right? And how it is through the named credentials, it is sending the request to Cloudflare endpoint, and then it is making an API calls to the PowerShell gateway, right? And through that, it is reaching the LM Studio endpoint, which is hosted on localhost 1234, right? And that's how we are making an API call, right? But as soon as you move to AWS Bedrocks, right, things change. So as you can see here, the Salesforce part still remain similar, right? But with the more controlled approach, right, where you can see that it is customers AWS account where we are managing the or maybe calling in APIs through the Amazon Bedrocks, and Qwen model is hosted here, right? And this is your CloudWatch and CloudTrail for your uh, tracking the logs and then looking at any errors happens through that, right? And then there are different controls based on the customer's compliance and security policies. You can define and configure the AWS environment, ensuring that, for example, AWS IAM with list privileges, model invocations, request controls, AWS KM, so basically encryption controls, and then you define your own VPNs, and then based on your infrastructure and security, InfoSec regulatories, right? Basically, so that's the other architecture. Now let's deep dive into the demo now and see that how it will work. Okay, so now we are in a Salesforce environment where I created this proof of concepts, and now I navigate to the AI duplicate assistant that I created. Let's go here, and as you can see that basically this is all built upon Lightning Web Component, the whole UI, right? And at the top, you can see that we have conversational interface with a free text input and suggested prompt, right? So basically, you can either click on it, right, which will basically take this text here and put it here. But other than that, you can feel free to enter your own text as well, right? And for this demonstration, let's use probably find duplicate accounts created this month. To change it to, let's say, this year, right? In the AWS architecture being demonstrated, Salesforce sends the instruction through the Apex integration service and customer-controlled AWS credentials to Amazon Bedrock, right? So right now, what we see the integration is with the AWS Bedrock after my successful POC with the locally hosted Qwen model, right? So Qwen is not querying Salesforce directly. It basically identifies the account as the primary object and translate the created this year into the created date, right? Filter boundaries, basically. So these are the filter. You can consider this year. It will match with the created date, right? It will parse the date, and then basically Bedrock invokes Qwen and returns constrained JSON in time, right? Basically. So the response can also contain related records, conditions, requested display fields, matching preferences, minimum confidence, and the permitted operations. Now, Apex treats a response as an untrusted input, as I mentioned earlier. Before retrieving any records, the validation layer checks the request against live Salesforce metadata. It validates the object, fields, field level security, filterability, operators, data types, pick list values, and supported relationships. Only validated fields are used to construct the dynamic SOQL. And the query execute in the user mode, right? API version 67. This ensures that the Salesforce security, sharing, and metadata remain authoritative, right? Now let's analyze it, basically. So now the analysis is running, right? And then basically you can see that on the right-hand side, the result is generated, right? And this is a synchronous communication, right? So basically for the synchronous proof of concept, Salesforce retrieves maximum of about, I would say, 500 to 1,000 candidate accounts, right? But right now I have, for example, out of those, there are some of them were identified as a duplicate, right? The model does not receive like those account records which are not basically the duplicates, right? And instead the Apex normalizes the data and builds the candidate pairs. So these are the candidate pairs, basically, as you can see that. For smaller result sets, every possible pair can be evaluated. For larger candidate sets within the POC limit, blocking keys reduce unnecessary comparison using normalized phone, website domain, account name prefixes, city and postal code characterizations, right? The matching engine then applies deterministic and explainable rules, basically, right? The current weighted model evaluates, for example, which I have set is normalized phone at 40%, website domain at 30%, account name similarity at 20%, billing address similarity at 10%, right? So out of that, the matcher also requires I would say corroborating evidence. 1 week similarity is not enough to create a duplicate group, right? So basically, we need to ensure that this threshold and the confidence level is met. And it's not only dependent on one record, which is like found a similar match and then just displaying as a duplicate. No. The results have now returned that Lightning Web component. So you can see that we are receiving a JSON response, right? The response is generated, evaluated by Salesforce, validated by Salesforce, and then displayed it on screen. Now, this is all LWC, which is currently displaying on the screen, right? So you can see that on the top, we can see the number of accounts analyzed, candidate pairs evaluated, and duplicate group identified. The chart shows the confidence distributions, basically this chart, right? And provide quick visual summary of the result set. Right? I will now expand to one duplicate group, right? So for example, as you can see that there are different confidence scores here and number of accounts that were found. It could be more, right? It could be 3, it could be 4, right? So basically, depending on the type of duplicates that you guys have today in the production, right? And then basically, let's expand Maple Reach Consulting Limited, right? So let's expand this one. And as you can see that it is showing the recommended master here. The accounts may share an exact normalized phone number, the same website domain, a higher or highly similar account name, or similar billing address, right? These explanations come from Apex matching logic, not from unsupported LLM conclusion, right? So we are making sure that it's validated in Salesforce and it completely depends on Salesforce data that is to the account records. The component recommends master account, right? Which is like based on data completeness, but the recommendation remains subject to user review, right? The data steward or the user can compare the records side by side and identify matching values and field conflicts, right? So for example, as you can see that basically these are two accounts. Let me scroll it down. So this is the account recommended master. These are two accounts, phone number, website, billing address, created date, and completeness, right? Basically. Next, we can review the account hierarchy. All right. So basically, and then you can also see the survivorship and conflict, basically. So which field has a conflict? So for example, here it says Maple Ridge Consulting and Maple Ridge Consulting. There is no limited, right? And there is no white space like the way it has this one. So review conflict, no conflict, review conflict, basically, right? But it's up to the user to basically make a decision on that. The next step you can see this is the hierarchy, right? And what it does basically, right? Basically, like it has basically identify parent and child relationship. So I don't see there is any parent and child relationship with Maple Ridge Consulting, right? And that could be affect the merge decision, right? So we want to make sure that we are considering the parent and child relationship as well before we merge it, right? And then the related record sections where it will show the amount of related records with each of the duplicate records, right? So for example, it has a contacts, one contact on duplicate. So there are two after consolidation, opportunities, cases, and basically it retrieves the chain of related records. So it could be custom or it could be standard objects, right? And the amount of number of records or related records associated, right? The merge preview, the next step is merge preview, where it will show that how it will look like after we merge the records, right? Basically, so it's kind of a high-level overview, right? And basically, it gives a complete overview about the accounts and even including the name, right? And how the surviving account will look like, and proposed field values as well, right? So basically, you can see that there are two related records, and this is only simulation only, right? Basically. And none of the accounts are modified at this stage, right? So the user can save the resolution plan, basically. So for the resolution plan, you need to basically ensure that you can run a safety check, right? So run the safety check against the saved Salesforce record. Groups with more than 3 accounts or hierarchy conflicts are blocked, basically, right? Before the execution, Apex reloads the records, verifies and selected masters, validate the duplicate members, and evaluate safety conditions, right? Uh, so let's basically try to save this one, and then we will run the safety checks. Okay. So, and then you can mark it as a mark reviewed as well and take an action. So basically you can save. Now we can run the safety check, right? So basically the safety check is basically ensuring that the merge won't fail and your record won't be lost, right? So basically, as you can see that two related records can be reparented to the surviving account. The operation deletes the duplicate account copies and cannot be automatically undone. Enter the merge to continue. So now basically you can merge it, right? But before you merge it, you need to ensure that you type in the merge. So that means you are now authorizing this operation, right? So basically now I will go ahead and perform the merge. So queue account merge, right? So once I do that, it will basically see that Salesforce queued job and open the save. So basically now it's all been merged, right? And now you can basically, or you can also see the consolidated plan that we just saved, right? And then you can go to that Maple Reach record, navigate to the Maple Reach record and see that how it will look like. So that's the whole idea, right? Now it has been merged and I can go to basically any of the record to see that if it is merged properly or not. So let's see my Reach consulting. Maybe I can search here. And then I can go here, right? So as you can see that it's now consolidated with two contexts as we see earlier. And basically now we can see that there were only two related contexts. It's been merged and the master copy is this one. It was as it was recommending earlier, right? So so the operation is completed and Salesforce confirms the surviving master account. This completes the end-to-end flow. Natural language request, customer control Qwen, Amazon Bedrock managed interface, constraint JSON intent, Salesforce schema describe validation, dynamic SOQL user mode, and Salesforce governed execution. The current POC proves its experience for a bounded data set. As an enterprise scale, the user experience would remain similar, but the processing would become asynchronous, right? Because if you have 5 million records and if you want to process duplicates on those accounts, synchronous will actually kill the browser as well as the memory, right? So the idea is that to process those records in asynchronously, right? The complete data set would be partitioned using the source system, migration batch, geography, date range, external identifiers, and normalized blocking keys. Okay? Result would be persisted as a duplicate group and presented through a prioritized data steward work queue. Users would review the exceptions, not 5 million records, right? Basically, that's very important to consider. The dashboard could show records scanned, partitions completed, duplicate groups detected, confidence distributions, review progress, approval rejection, blocked merge and failures. This POC therefore basically demonstrates a working customer control private AI architecture today while providing a clear path towards enterprise scale processing, configurable matching, operational monitoring, and governed automation. I hope you like it. And then if you have any questions or if you're looking for extending the solutions, reach out to me. I'll be more than happy to do that. Or maybe if you have any questions, please reach out to me. I will also make this POC available as a open source on GitHub soon. So you can basically try it on your own as well. Okay. Thank you so much, guys. Have a wonderful day.